The first derivative will tell us where the function is increasing and decreasing. But what does the second derivative tell us? Well, if you think about the second derivative, it's the derivative of the derivative. It's how fast is the, how fast is the slope changing, right? So what this translates into is giving you information about the shape or the curvature of the curve. Really, especially when you go into Calc 3, you really have to think of the second derivative as being, in some sense, a measure of curvature. So we need some definitions. If my curvature is like this, if it's curving up, I call this concave down, right? Because it's sort of, the cave is down. And if the curvature is like this, no, maybe I'll make it more obviously down, right? More obviously down, concave down. More obviously up, concave up. And we saw a preview of this last week when we talked about that last problem on the worksheet. But just kind of keeping this in mind, we could call it convex and concave, but it's just a bit easier to think of it as concave down or concave up, right? And often you'll see, we'll say CD or CU, concave down, concave up. And it turns out that if my second derivative is positive, then I've got my picture being like this, concave up. And if my second derivative is negative, then I've got something that's like this, concave down. Now you'll see in the pictures I drew, the first picture I drew, everything was going up. So like the whole first derivative was positive. But here you can see at some point there's going to be some maximum. So the first derivative is positive, the first derivative is negative. But here the second derivative would be negative for the whole part of the interval, right? Now you can imagine making these things meet up, right? Let's do like that. And then there's a point here where it changes from concave down to concave up. So that point is called an inflection point. So let me define that really. An inflection point is where the graph changes from where the graph changes concavity, right? Because it could be changing from concave up to concave down. Let me put another one in here, right? So we got some extra stuff. So here, this is changing. Now that's concave down. Now this looks like it's going concave up again. So if I have a graph like that, I'll have a whole bunch of points in there. And what's happening is at those points, the second derivative is changing sign. So most often, the second derivative is going to be 0 there, okay? Now, it is possible to have something like a horizontal tangent, so then you wouldn't have no second derivative, and that would also be such a thing. But for the most part, for an inflection point, you will have a second derivative being 0 there. So very much like what we did for the first derivative in terms of increasing and decreasing, we're going to do for the second derivative to look for concavity, right? Oftentimes, by the way, you can graph your function if that's what you're looking for. If that's what you're trying to do is just graph the function, you can graph the function just by looking at the first derivative test. You don't necessarily need to look at the second derivative just to graph the function, but we will ask you to look at the second derivative just to give more information about what's going on. And so the second derivative test is just sort of a way to kind of codify this. So second derivative test suppose f double primed of x is continuous near C, right? So this is, again, a different way, rather than what we did. You can look at the second derivative at your critical point and use that in order to determine whether it is a maximum or a minimum. Okay? So if you have a critical point, and then the second derivative is positive at that critical point, then f, okay, so let's to think about it. If the second derivative is positive, the function must be concave up, so that must look like that, so that must be a minimum. Then f has a local minimum at x equals c. Similarly, if your second derivative is negative, right, that would imply you had a situation where your thing was concave down. Well, if it was concave down, that looks like it would be a maximum. So you can use the second derivative test instead of the first derivative test to check so rather than doing a sine chart for the first derivative, you can check the sine of the second derivative. So this is just an option. I personally tend to use the first derivative test, but what I like to do with the second derivative is use it as a double check, because sometimes you'll make an error and then things don't work out, and that is a great way of letting you know, okay, something went wrong. So let's take a look, though, just really quickly from the other example we did. Let me get rid of this real quick. Just going back to this function. Right? We had taken the first derivative. We had 36 plus 6x minus 6x squared. Now we can also take the second derivative. Our second derivative is going to be 6 minus 12x. Okay? So we can do a couple of things with that. First of all, we can find where it's equal to 0. Right? So minus 12x equals negative 6. X equals 1/2. Okay, so if I do a sine chart for the second derivative, I can see there's only one point on the sine chart, x equals 1/2. When I'm below 1/2, right, if I'm going to put in 0 here, right, I'm going to get something positive. And when I'm above 1/2, I'm going to get something negative, right? I'm going to put 1 there. Okay. So this is my sine chart for the second derivative. That's going to tell me that this function now is going to be concave up until I hit 1/2, and then it's going to be concave down the rest of the time. And I've got an inflection point at this 1/2 because my second derivative is 0 there. All right. So I can use this. You know what? I'm just going to use this really quickly. Oh, why did I? Because I think I have the other numbers written down here. So I don't want to make this video too long. But I can use what I figured out. Remember, we figured out that 1, 2, 3, 4. 1, 2, 3, 4. I can see it goes through 0. I know I have a negative 2. And, okay, we'll just call it 10, 20. Ugh, that's not even that good. 30, 40. All right? And then Because up here I have to go to 80, right? 10, 20, 30, 40, 50, 60, 70, 80. Perfect, right? So let's do that. Anyhow, so at f of negative 2, I had negative 44. I know I go through 0. And then at f of 3, I had my maximum at 81. I'm up here. And it changes inflection somewhere here, and I could figure out that point, but again, I don't want to make this video be too long, so we can put in the number to figure out the point of inflection, and we can kind of generally know that our graph is going to look like that. Okay? Just as a quick graph.